Okay, so section 4.5 deals with the dimension of a vector space. Okay, dimension of a vector space. And first of all, what is dimension of a vector space? Well, on the next page, okay, they have the definition here. And this is the definition. So they talk about finite dimensional space, but here's really the big thing to take away from this definition. The dimension of a vector space V, written as DIMV, is simply the number of vectors in a basis for V. Okay? It's the number of vectors in a basis for V. Okay, so like for example, let me go to the whiteboard here and do a quick example. Let's talk about, well, Binyam, we're going to get there. Let's talk about, I want a basis for three-dimensional space. Okay. So I'll write down 1, 0, 0, and 0, 1, 0. Now, is that a basis for three-dimensional space? 1, 0, 0, 0, 1, 0. I mean, is that a, well, let me, is that a basis for R3? That's what I'm asking. Okay, Solomon says no. Why not? Why isn't? Those vectors are linearly independent, and the vectors 1, 0, 0, 0, 1, 0, they live in R3. Okay, but do they span R3? Do they span, do they span R3 space? Does that basis span all of R3 space? Solomon says they don't span R3. Binyam says no. Oh, why not? Can you give me a vector that's not in the span of those two vectors? Okay, E3.Maybe give me, yeah, like 0, 0, 1. Right, that's right. Or like 2, yeah, 1, 5, 6. Yeah, so now I'm getting a lot of examples. Or 2, 4, 7. Yeah. There's no way 2, 4, 7, that vector, could be written as a linear combination of these two vectors here. Okay? All right, so that's not a basis. That's not a basis. How many more vectors do we need to have a basis for R3? One more. Okay. So what if I had then 0, 0, 1? Would that give me my basis for R3? It would. The span of that collection of vectors is equal to R3. And those vectors, by the way, are also linearly independent. Linearly independent. And this is why we call R3 three-dimensional space. R3 is three-dimensional space. because of this. You need, I mean, that the dimension of, but I mean the dimension. Okay, the dimension. I want to write nicely here. Hold on, let's do it good. Let's do it well. What's the dimension of R3 equal to? That's right, Solomon, it equals 3. Three-dimensional space. So we have three-dimensional space, two-dimensional space, and you've heard these terms your whole life, but that means the dimension of a vector space is the number of vectors in a basis for the space. And I think that's the key idea that that we have. Now, if I go, are there any questions? I have a question for you. What if I change that third vector to 0, 0, 2? Instead of 0, 0, 1, suppose I had 0, 0, 2 for my third vector. Would those three vectors, 1, 0, 0, 0, 1, 0, and 0, 0, 2, would those three vectors be a basis for R3? They would, absolutely. So a basis is not unique. A basis is not unique. And, they're still linearly independent. Right. And they still span R3. So, okay. So let me go back to the book if we're good with this. Are there any questions at all? All right. Thank you, Kevin. All right. Well, now let me go back to the book real quick here. And this is really, this is really the key. The key. So, like, for instance, when we had the span of those two vectors, v1 and v2, that example we saw, example 7 in section 4.4, the dimension of that space is 2. Isn't a plane two-dimensional? Isn't a plane two-dimensional? How many have heard that term before, that a plane is two-dimensional? Yeah. Yeah, well, that's because a plane is the span of two vectors, two linearly independent vectors in R3. And so, but it's two basis vectors that are needed to generate the plane. So the dimension of a plane is equal to 2. A plane is a two-dimensional subspace of R3. Okay, is that any questions on that? I think the examples, it's very straightforward. I want to have a little time to talk about the MATLAB assignment number 2 a little bit. But here they have a picture 2 in figure 1, some sample subspaces of R3. They show a one-dimensional subspace in A, two-dimensional subspace in B, and in C you have the three-dimensional subspace, which is everything in R3, and then the two-dimensional subspace. So a lot of cool stuff here. Are there any questions at all? Okay, let me stop the recording.